So, in this new video, we will consider the electronic classification system. These are given to enable welders to understand the electrode capabilities regardless of the manufacturer. The main role is from American Welding Society, and these are the classification system. Most of the electronic designations start with the letter E, followed by 4 or 5 digits. Letter E designates electrons as suitable for electric arc welding. There are other kind of welding consumable also, like fluxes and wires. So this E stands for electric arc welding. This prefix appears on virtually all stick welding electrodes, regardless of their specific classification. Following the E designation, we have first 2 digits indicate minimum tensile strength of deposited metal materials in thousands of pounds PSI, pounds per square inch. For example, in E6010, E means electric arc welding, 60 is 60,000 PSI, while E7018 electronic is achieve 70,000 PSI, minimum tensile strength. Third digit indicates welding position. 1 indicates all position, means all position means electrodes can effectively work in flat, horizontal, vertical, and overhead positions. Number 2 and 4 designate flat and horizontal positions, and 3 indicates flat position welding exclusively. So these are the 1, 2, 3, 4. We have discussed. 1 means all positions, 2 means flat, 4 means horizontal positions, while 3 indicates flat welding position exclusively. The final digit indicates electrode coating type and current characteristics. This number provides information about the flux coating composition, current polarity requirements, and penetration characteristics. Understanding these welders select the welder compatible with the available power sources and decide weld characteristics. So we will discuss now common electrode classifications. We use E6010 and E7018. E6010 means it is a 60,000 PSI electric arc welding. PSI electric arc welding. 1 means odd positions, and 0 means celluloid based coating. It works that works with the DC reverse polarity. So if DC polarity is a forceful arc that burns through the paint, rust, other contaminants. So we are using in root pass actually. E701 is another electrodes we are using. It is represents low hydrogen classifications in the structural welding, requiring high strength and toughness. So 70 is a 70,000 PSI. 1 means all positions. 8 means iron powder coating, and DC reverse polarity or AC, producing a smooth slag-free finish, excellent mechanical and minimal hydrogen content. So 8 suffix means iron powder coating, DC reverse polarity or AC. Here we have another three electrode classification E6011. It is one indicates all position, excellent I suffix produces all position capability. This one with the excellent gap bridging properties, making electrons popular for maintenance, welding, and repair application where joint fit up may not be less than ideal. So E6013 means it features rutile-based coating. This provides easy arc starting, smooth operation, and minimal spatter protection. This general work with well with the sheet metal welding, light structural work applications where cosmetic appearance matter more than the maximum strength or penetration. That is three. Three have this rutile-based coating. And 7016 is a low hydrogen, just like 8 here. It's low hydrogen cadmium iron powder addictions offering excellent mechanical properties for pressure vessel and structural applications. It's careful storage, maintain low hydrogen content and prevent moisture absorption, so can cause weld defects. So these are the details of electrode classifications. Next we will move on to the main two electrodes we discussed, that is E6010 and E7018.
So what is the F number of E6010? It is 3. F numbers, like we said before, it is usually provided to based on the usability and operating characteristics. It can affect the skills required by the welder to produce a sound weld. The usability and operating characteristics are the keyword. These are the keyword, and F numbers are based on this usability and operating characteristics, and it will affect the skill of the welder to produce a sound weld. So F number 3 is assigned to the so like we said, the F number is 3 for this E6010, and it is assigned to cellulose coated electrodes. This cellulose coated means it has a deep penetration, strong arc force, and suitability for all position welding, especially vertical down and root passes in the welding. Other electrodes in this F number often include E6011, and it's also fast freezing actually. So our question was E6010 is suitable for APL 5LX52. It is suitable for APL 5LX52, particularly for the root parts in the pipeline application. This is very common choice in the gas industries and widely used in the standard welding procedures qualified under codes like API 1104. So why it is suitable? Deep penetration. It have a deep digging arc. It provides an excellent fusion and penetration. It is ideal for achieving a strong sound root pass in the open root pipe joints. It is designated for all position welding, usually vertical down, particularly effective for vertical down and stove pipe welding techniques commonly used in the cross-country pipeline construction. So it can produce a minimum tensile strength around 62 psi. So it requires a 552 also requires a minimum tensile strength 66,000 psi, which means that E6010 alone may not meet the full tensile strength requirements of the base material. That's where we are using E7018. So common combination, because there is strength difference, E6010 is always used in combination with the higher strength filler material for fill and cap passes like E7018, and this combined procedure ensures that final weld joint meets or exceeds minimum tensile strength of the APL 5L X52. So E6010 is used for deep penetration and for root welding, but it alone may not be sufficient to achieve the minimum tensile strength of the ABL5L, that is 66,700 psi, which it is used in combination with the electrode E7018, which has a strength of 70,000 psi, and it's also so why APF 5L X52 requires a minimum tensile strength of 66,700? Because the specific value is the essential part of APL 5L standard specification designed for demanding conditions of oil and gas transportation. It is required as per the code. So, reason is standardized mechanical properties. Number X62 indicates minimum yield strength of SM by S of 52,000 psi. Associated tensile strength is 60,700 is a complementary mechanical property specified by the for PSL 1 and the standard quality level. It is a product specification level to ensure pipe has a balanced strength and toughness profile. Safety and integrity of high pressure applications like oil pipe transport. The specified equipment ensures manual can withstand operational stresses and pressures without rupture. A higher tensile strength provides a safety margin above the yield strength, preventing catastrophic failure for unforeseen conditions. Structural integrity. Tensile strength measures the ultimate breaking point of the material. By specifying high minimum tensile strength standard ensures that there is sufficient capacity to handle peak loads, pressure surges, external forces encountered during installation and operation. Material uniformity. This ensures that consistency across all pipes are manufactured to this standard, allowing engineers to design reliable pipe systems. Differentiation from the lower grades. This strength requirement distinguishes X52 from the lower grades like grade B, which has a minimum tensile strength of 60,200 psi, making it suitable for application requiring higher pressure rating and better performance. So next question is, can F number 3 and F number 4 can be used in combination? Yes, it can be used in combination. It is very common and effective welding procedure widely used in the pressure piping industries. How combination is typically used? It is used, E6010 is used for the first or root pass due to deep penetration and digging arc characteristics. It is ideal for achieving a sound fused root bead in an open root pipe joint. But E070 for fill and the cap passes. E7018 or E7010 is also higher strength used to subsequent fill and pass operations. It has low hydrogen electron. It can produce high strength, tough, and crack resistant weld with better mechanical properties and impact toughness. So code compliance. As per ASME section 9 welding codes, use of two different machines is permitted provided that WPS is properly qualified. Procedure qualification required. Specific test person will be welded using exact combination of the filler materials and passes as proposed in the WPS. This test scope is then subjected to mechanical testing, the destructive testing, bed test and tensile test. Combination must ensure that final void joint meets the minimum tensile strength requirements of API 5L X52 base material, that is 66,700 psi. Since 6 along is a minimum tensile strength of 60,000 psi, higher strength filler materials like E70 or 8010 which provides 77 psi or more in the subsequent passes are crucial for achieving the required overall joint strength. Essential variable. Changing F number of the filler material is an essential variable for the welding procedure to trigger. It means is that a specific combination must be documented and qualified. In summary, combining number 3 and number 4 electrode is a standard qualified procedure that can leverage the distinct advantages of each electrode to produce a robust and reliable weld for a pure 5L X52. Oh, so finally, what is the F number, G number, A number, and of API file system? Break them up. For us is P number is P number is one for it's a low alloy carbon steel grouped under P number one. It includes carbon manganese keys. Second is group number also one. It is a subgroup of carbon within the P number category, and whenever we require impact testing, that we already discussed. Then A number classifies the chemical deposited welded material composition of the material, not the base pipe itself. It will depend upon the specific welding procedure. For filler materials commonly used within APL 5L X52 such as E70 deposited material typically falls under A1 category, that is carbon 2.2% starting. The F number classifies the filler material used for its usability characteristics and based on the usability characteristics and this usability and operational characteristics. So usability and operational characteristics within the group number one. Sorry, A1 number. Sorry, F number we are discussing. So as previously discussed, the different filler materials are used for different passes. F3 for root pass with the E6010 electrode, and F4 for subsequent filler run and the cap passes using E7018 electrode. So PSL2 requirements means that there is stricter requirements than the PSL1, that is particularly considered chemical composition like a carbon equivalency and mechanical properties like impact testing and mandatory non-destructive testing. These requirements do not change P number and group number, but to make the welding qualification more rigorous. For example, Sharpie impact testing, while not in the PSL1. So another question arises: why we are using E6010 as a root pass material? It makes another question: why we are using E6010 electrode? Because it is used in the root pass because of its fast freeze property. This property, because of the cellular flux coating, creates a very forceful digging arc and a weld pudding. It solidifies rapidly, fast freezes. This property is very crucial for out-of-position welding. It allows the welder to control the molten puddle, prevent it from sagging or falling out, especially in the vertical and overhead positions, common in the pipe welding, and bridging gaps. A fast freeze action helps to manage the variable root gaps, ensuring a proper penetration without blowing through the joint. Contaminants. The aggressive burn prevents through the rust, paint, and dirt, effectively common situation in the field welding. So that's why it is because of deep penetration and fast freezing property of the E6010 makes it useful in the root pass. But then why we are changing to sudden after root pass we are using 7018? Why? First thing is that we are using base material as API 5L X52. Its minimum specified tensile strength is 66,700. But if you are using only 6010, that is for root pass cellular based coating, it can give deep penetration and fast freezing so that it can be useful in the root pass, but have a problem. Its tensile strength is only 60,000 psi. So is to comply with the specification, we need 66,700 for the X52. We are doing the weld joints with a combination of E6010 and 7018. So 7018 electrodes have a what to say have a tensile strength of 70,000 psi in combination with 60,000. We'll get an average tensile strength of the weld joints as 66,700. So that is one reason. Second reason is we are using 7018. It is used for its low hydrogen property. So what is 18? 70 we said it is 70,000 psi. 1 is the all position welding, and 8 is for iron powder coating of the electrode. So with the iron powder coating, what is happening? We are getting a, so this 8 means it requires a high, it is used for structural welding, high strength and toughness, low hydrogen classifications, and iron powder coating with that requires a DC reverse polarity. DCEP, electrode positive, DCEP. This direct current EP that will we discuss in during the welding videos. So, or AC providing a smooth slag-free welds with excellent mechanical properties and minimal hydrogen content. So, minimal hydrogen content, power, iron powder coating, and DC reverse polarity as the peculiarity of a 8 suffix, and it is iron powder coating with the this DC reverse polarity. So E0 is selected primarily because of the first we told about the tensile strength. Second is its low hydrogen property, and it also has a high deposition rate. So low hydrogen property is that main reason for using E7018 is very low moisture content in the flux. It drastically reduces the risk of hydrogen-induced cracking in the high-strength or thicker steels. This is critical for structure and pressure-containing welds, where the integrity is non-negotiable. High deposition rate means flux coating contains iron powder, which contributes to high fill rate. It is effective for the fill and cap layers of the weld joint. Excellent mechanical properties. E7018 produce high strength ductile welds with excellent impact toughness. Making it preferred for choice for critical applications. So what is hydrogen induced cracking? It is also called cold cracking or hydrogen embrittlement. It's a delayed form of cracking. It occurs in the weld metal or heat affected zone after the weld has cooled down, sometimes hours or days later. It is caused by the presence of key factors. That is why it is a delayed form of cracking, it is called. So susceptible material like high strength low alloy steels. Hydrogen source is moisture in the electrode flux base material or atmosphere. High stress, residual stress from the welding or applied loads. A temperature below 300 Fahrenheit, that is 150 degrees Celsius. All these four factors will contribute to the hydrogen-induced cracking. So how it is prevented? It is prevented by minimizing the amount of hydrogen introduced in the weld and managing the cooling rate and the stress. Use low hydrogen electrodes like E7018, and it should be stored
in a specialized rod ovens to keep the moisture out after opening the hermetically sealed container. Hermetically sealed container is an important word. Then proper material preparation. Base material must be clean, free of rust, grease, oil or paint, as there are sources of hydrogen. Preheating. Heating the temperature before welding slows down the cooling rate of the well, this lower cooling allows more time for the trapped air hydrogen to diffuse out of the weld area safely, preventing the buildup of the critical. So, why we are using preheating to make a slow cooling rate. So, preheated will have slow, and it will give more time to hydrogen to escape, to diffuse out of the weld area safely, preventing the buildup of critical levels. And also we are doing post weld heat treatment in critical applications. A controlled heating cycle after welding can further ensure hydrogen removal and reduce the residual stress. So far we discussed about the electrode. Now next section we will move to question like why we require APR 5 and X52 as the base material. The next video. So finally, why we are using this APF 5 and X52 in our PSL2? It's a specific type line for use for oil and gas industry, pipeline transportation. It has a pipe minimum yield strength is 50,000 pounds per square inch. It means it can withstand significant pressure before permanently deforming. It's also suitable for high pressure applications, and it has a product specification level 2 means it's a higher quality level than the PSL 1. It includes stricter requirements for chemical composition, mechanical properties, and testing. So this results in a pipe with an enhanced toughness, impact resistance, and overall reliability, especially in demanding conditions. Key advantages are high pressure pipe transportation. It can safely transport oil or gas under high pressure. Demanding environments like source services with environments with hydrogen sulfide offshore applications. So like harsh environments, we can in that environment also we can use this. We can transport the water in high pressure. Reliability and safety. Stricter requirements of PSL ensure a higher level of safety and reliability in critical pipeline applications. Toughness and impact resistance. This is manufactured to have high toughness and impact resistance. So that's why API 5L X50 to PSL2 is chosen when a strong, reliable, high performance pipeline is required in challenging operating conditions. That's all for this video. We will continue in the next video with this one. Okay, this is for APA 5L grade B PSL2. This is for 700, 1200, 1000. We are used in Madinasayat. PS and the section piping also.